And number 11, we're creating and interpreting a confidence interval, and I'm going to show how to use StatCrunch to do this. And so this problem here, it's a story problem about a certain type of virus, and we have a sample of patients. We're trying to find the mean incubation period. So if we open up StatCrunch, we want to go to Stat, and we have to notice here what information we have. We have the sample mean, the mean from our sample. We have the standard deviation of our sample, but we don't have the population standard deviation. And because we're finding a mean and we don't know the population standard deviation, our distribution of sample means will follow a t-distribution. So don't use z, use t. We have one sample and we have the summary data. So our sample mean we enter, and then our sample standard deviation we enter, and our sample size, and we're creating a confidence interval, 95% confidence. We hit compute, and it gives us our lower and upper limit. Be sure to round to the correct number of spaces mentioned in the problem. And so just how we interpret that interval, it's a 95% confidence interval, so there is 95% confidence that the mean incubation period lies between the lower and upper bounds of the interval. For number 12, we're looking at a hypothesis test, and it gives us our null and our alternative and our sample size. And down here we get the information about the sample that we gathered, the sample mean and the sample standard deviation. Now we're looking for the t-test statistic, which is given away here by the letter T, but also we know we don't have the population standard deviation, so we're going to need to use the t-distribution. So I'm going to go to t-stats, one sample with our summary data. And so that sample mean 18.1 for this problem. Type in the standard deviation and the given sample size. Make sure our hypothesis test matches up with our parameters, and it says we're looking for a left-tailed or less than alternative, so I'm going to enter that. And when I hit compute, I get the test statistic here. I also get the p-value. So I can go ahead and answer part A based off that. And for part C, it says to approximate the p-value. And you can do that if you're using a table, but since we're using technology, we can get the precise value. So 0.038, I would look and say that's in between 0.025 and 0.05, so that would be the approximation. I know the p-value is in between there. Now to get what this looks like, we know just from the left-hand tail less than alternative hypothesis, that C is what we're looking at. If this was a greater than symbol, we'd be looking at A, and if it's a not equals to, it's when we're doing a two-tailed both ends test. I mean, we can also see exactly what we're looking at here. If we go to Stat Calculators as a t-distribution calculator, we're doing a less than. The degrees of freedom is one less than the sample size, so since it was 19, one less than that is our degrees of freedom. And then if we enter our test statistic here, we get a graph that illustrates the p-value. It shades the percentage of the distribution that is less than this critical value. And you'll notice that comes out to exactly the same p-value we got earlier. So going back to the last part of the problem, if we are doing this hypothesis test with a significance level, our alpha is 0.05, do we reject or not? If our p-value is less than alpha, we reject. If it's greater than alpha, we do not. And since our p-value was definitely less than 0.05, we are going to reject the null hypothesis. For number 13, we're working with another story problem and hypothesis test. And it has long been stated that the mean temperature of humans is 98.6. So that's the basis of the story problem. That's our null hypothesis. And here we have some researchers who want to test if the mean temperature is actually less than that. So we're going to go into StatCrunch. We'll see from our information here, we have the sample mean, we have the sample standard deviation. We do not have the population standard deviation, so we have to use t-stats. And so we'll find that sample mean, 98.4 in this example, sample standard deviation, and then make sure you get the right sample size. There's only 50 adults, but these adults are being measured their temperatures several times a day over a 3-day period. So there's a total of, in this example, 225 measurements in the sample. And so our hypothesis test was that the null is 98.6. And then we were checking to see if it's less than that. So we're having a left-hand, left-tailed test of this. And so when we hit compute, we get our t statistic, and we also get the p-value. And we're going to use that p-value to test our null hypothesis. If it is less than alpha, we will reject the null hypothesis. And this is actually less than 0.01. So since it's less than alpha, we will reject our null hypothesis and accept the alternative that the mean temperature is actually less than 98.6. For number 14, this story problem is about manufacturing, and any type of manufacturing that needs to have consistency could use a hypothesis test like this to make sure the product they're making is consistent with the expectations. In this example, a golf association working with golf balls, they have to be a certain size. And so before we jump into that, this is the size they have to be. That's going to be our null hypothesis, that the golf balls are that size. And our alternative is just going to be not equals to, because we want to check if the golf balls are too big or too small. Any deviation from this expected size would be an issue. So we take a sample of the golf balls produced, actually measure how big they are. Looks like most of them are pretty close. And we're going to use that data in StatCrunch here to run a hypothesis test. Now we don't have the population standard deviation, so we're going to use tstats, one sample, and we actually have the data this time, and it's in that first column. It got imported. We want to type in what our hypothesis, our null is, and we're checking for not equal. So we can hit compute, we get our test statistic, and we get the p-value, probability value of that test statistic. And so if this is greater than alpha, we will not reject the null, and if it's less than alpha, we will. So let's check what alpha, our significance level, is. It's 0.05. This is much bigger than that, so we do not have enough evidence to reject the null hypothesis. And in terms of our story problem, rejecting the null would have meant that we accept the alternative that these golf balls do not conform to the standards, and we don't have enough evidence to do that. And so, or do not reject the null, there's not sufficient evidence to conclude that the golf balls do not conform to the association standards. For problem 15, this problem is about calcium and tree growth, basically seeing if the level of this natural occurrence has changed over time. So in 1990, we knew the concentration of calcium in the precipitation was at a certain level. And then we're going to gather data later in time and just see if it's changed at all. So our null hypothesis is that level we had back in 1990. And then we're just looking to see if it's changed one way or the other. So our alternative is not equals to, whether it's gone up or down. And so that's what it says here. See if it has changed since 1990. So our 2007 data is right here. I'm going to open that in StatCrunch to see if there's enough evidence to say it has changed. And you'll notice part B says we want to do a confidence interval. So I'm going to do that. I need to use t-stats because I do not know the population proportion, or sorry, the population standard deviation. I just have this data here from my sample. And so I'm using t-stats. There's my sample in that column. And then I'm doing a confidence interval. And it says 99% confidence interval. So once I hit compute there, I'll get the lower and the upper limits. Now we want to interpret that in terms of the problem. Does that sample evidence suggest that the calcium concentration has changed since 1990? Well, our null hypothesis is actually in between the lower and upper limits. So it's definitely plausible that that null hypothesis is true. We would not want to reject it because it's in between the lower and upper bounds here. So that is why we're choosing this option here. And we don't have enough evidence to really conclude that the calcium concentration has changed.